and thank you all for joining us today for this educational Innovize webinar. My name is Caitlin Nyan, and I'm part of the marketing team here in the Innovize Portland office. In this webinar, we will examine this new age of real-time data fusion using IoT, Scada, GIS, and hydraulic model results that can empower engineers and operators to quickly monitor, analyze, respond, and optimize their water and wastewater networks. For those of you who may not be familiar with Innovize, we have a long history of providing high-performing, innovative software solutions. Our intention is to make sure that in your work, you can design, model, review, and manage with confidence. This also means that we strive to provide excellent customer service and support, and that we offer continuing education opportunities like these for engineers and others in our industry. Innovize offers a library of software programs, including Scada Watch, which you will see today. Now, on with our presentation. I'd like to introduce our presenters. Today's presenters are Paul West and Brett Singley. Paul West is our guest speaker today and will be presenting several case studies on the use of IoT and Scada to improve water and sewer operation. Paul is located in Atlanta, Georgia, and a graduate of Georgia Tech. He has over 20 years of water utility and consulting experience with expertise in water and sewer operations, master planning, hydraulic modeling, conveyance design, Scada, and IoT. In 2011, Paul started Smart Water Services, a company specializing in the development of innovative water IoT products and real-time modeling services for the water and utility industry. Some noteworthy accomplishments are that Paul's company was the first to commercialize hydrant telemetry product in the U.S. capable of water hammer detection. Paul also conducted the first integrated water distribution system IoT, Scada, and hydraulic modeling project in the U.S. in 2012, which he will be sharing as a case study today. Paul is also a part-time consultant at Brown & Caldwell, a member of the AWWA Engineering Modeling Application Committee, and a local Georgia Association of Water Professionals. Also, Paul has been involved in Scada Watch projects in the past, including the integrations of IoT products, which we will be discussing during this webinar. Before joining Innovize, Brett Singley worked at an international consulting firm as the National Distribution System Modeling Lead for the United States. He has worked on dozens of master planning and modeling projects over the years, all over the country, as well as a few international projects. Since joining Innovize in 2015 as a client service manager, he has transitioned to a product management team in charge of all potable water products in Scada Watch. He is passionate about improving workflow processes and using computers to automate the boring parts of your job that don't require critical thinking. Thank you again for joining us. Would you like to start a discussion, Brett?
Absolutely. Welcome, everyone. Thanks for joining us. We have an agenda here for you. We want to first emphasize the fact that this presentation is not going to be a presentation about how using IoT and the Internet of Things will have 1 billion devices online and everything will be completely digitized perfectly by 2015. We're actually going to talk about practical uses of IoT devices. That we're gonna talk about specific case studies where Paul is gonna show how he has used them to solve operational problems in water and sewer networks specifically. The case studies will kind of highlight solving water hammer problems at a pump station, water quality problems in 2 interconnected water systems, and the actual first one we'll talk about low pressure problems during a big water line maintenance project. Throughout, I will be showing off how Scada Watch has been used in the past. We've had some projects with Paul in the past, as well as how I can use some of the data that Paul had for this presentation, just to showcase how you'd look at it within that software. Paul, would you go ahead and kind of get people up to speed on the background information that might help them understand things as we go through this presentation?
Okay, great. Good morning, everyone on the West Coast, and afternoon on the East. And thank you, Brett, and special thanks to Innovize for inviting me to participate in the webinar today. So let's get started. So water utility operators are facing many challenges these days managing their water and sewer networks. They're having to deal with, in addition to their day-to-day tasks, pressure and water quality problems that lead to customer complaints, low chlorine residual problems, pump station operational problems, vibration, wear and tear, water hammer problems, planned and unplanned pipeline outages. In a lot of utilities across the U.S., every time it rains, they're dealing with CSOs resulting in property damage or the environment. So these just represent a few of the problems that operators face every day. So the question is, how can we empower water utility field and office staff, engineering, consultants, and technology vendors to more efficiently manage these problems together? Sorry about that, a little bit of delay. So how can real-time data and systems integration help improve operational performance? For decades, water utilities have relied upon their Scada systems for real-time information, but there's always been an inherent challenge or problem. Scada systems are really designed and built for high reliability and security, and due to the consequence of failure or loss of customer service, these systems tend to be expensive. They can lack geographic coverage in our large water and wastewater networks. And some of this is due to just the inherent high power requirement. So these systems tend to require AC power. They need to be installed really in facilities, pump station tanks, and control valves. And it's a bit of a challenge to make traditional technology work out at remote locations. So unfortunately, this leaves hundreds of square miles sometimes for large water systems without any monitoring other than getting the customer complaint call. And by that time, it's too late. So in rushes the age of IoT or Internet of Things, and I'm sure all of you on the call have heard a lot about this in recent years, and you may be using IoT at your utility, but maybe it's not exactly clear for some of us how IoT can be a game changer for your utility. So key to IoT technology that's important is it's low power, small footprint, portability, due to various wireless network options that are available these days, and most notably cellular is very common. And oftentimes IoT systems and products tend to come with pre-integrated sensors, so they're much easier to deploy and get up and running. And in recent years, IoT technology vendors have developed some very powerful turnkey solutions that really benefit water and sewer operations. So how do we choose the best IoT product or platform for your particular water utility? So there are a lot of options on the market these days, from do-it-yourself systems all the way to the complete turnkey systems. Our experience in recent years is most utilities tend to opt for the turnkey solutions just because operations and engineering are wearing so many hats. There's just limited time to do things on your own. I would want to mention a special group here in the city of Atlanta that's developed their own system, kind of a DIY system using innovative LoRa wireless technology. And if you're going to be at WEFTech in New Orleans next week, definitely check out City of Atlanta's presentation, doing some really interesting things with sewer manhole level monitoring and notification in their system. So number two, some vendors are creating very specific products that do just one thing, while other systems are more open to different applications. So it's always important to really step back and not only look at what your current chronic problem might be that may be driving a selection of IoT, but what might you be looking at in the future? And is the platform that you're looking at going to be able to work well in other situations? And I really encourage utilities to experiment with several different options. It's really difficult to know how these systems work until you get immersed in the technology. Another kind of important feature that comes up in water and sewer operations, obviously Scada is designed for monitoring and control, but IoT devices, most are limited to monitoring only. And so sometimes it's important to have some control capability. For example, do you want to control a flushing valve on a hydrant? Do you need to control a gate at a stormwater pond? Now, IoT is really best used for low consequence of failure type applications. You really aren't wanting to use that on large pump stations that serve a lot of customers. You really need to stick to your traditional systems for that. But a lot of cases, IoT is really the perfect match for these hard to reach places in our network, water and sewer network. The fourth feature that's important is your system going to be proprietary or open? Do you have control of the core program that's running the device with the RTU? Do you have some control over the communication? the website? Can you customize it, or is it just for what you get is what you get? So another thing that's really important is, does your IoT system, would you be able to integrate that with Scada in the future if you so choose? A lot of operators are tending to use the more lightweight website applications, but they do like the options of being able to integrate at some point with their existing Scada. So before we jump into some case studies, Brett is going to take a quick tour of Scada Watch, just for those folks on the call that are new to the software. So Brett, you want to take a tour?
Yep. So actually, yeah, we'll do this first. Scada Watch, for those of you that haven't ever seen it before, the idea behind Scada Watch is that it can be kind of a central hub for a lot of the data that Paul's been talking about. So we can bring in that Scada data. We connect directly to the historian in a read-only format, so we can bring data from the historian into Scada Watch. We can bring in the time series database from any IoT devices into Scada Watch. And then we also have a connection, because we've been traditionally a really heavy modeling company. We've also got a connection back down to the hydraulic model that can go actually back and forth, helping update your model, but also bringing some model results back into Scada Watch. The ultimate goal is getting it in a format so that it can be used by people across the municipality, right? So management, operations, and engineering, they might all want to look at different things. We want to make that available to them. So what it looks like as a user is it's a web-based, fully customizable to what you want to look at. So it's you got your own user logins, you make your own workspaces, really simple to create, to monitor, analyze, and visualize your system data. And if you've seen any webinars in the past, you know how simple to complex we can make some of these things, you know, all the way doing full-on infrastructure leakage index reporting and things like that, to simple mass balance calculations. What it looks like is, you can see there's kind of a map on the top that you can look at your sensors and a bunch of different ways to visualize data. At the bottom there was a mass balance that shows what you can do to figure out usage patterns in a water system. Each individual of these little windows are called dashlets. You can see they're very easy to move around and manipulate to really get it fine-tuned to what matters to you and your job. Now, I've got a couple poll questions, and I'd like to bring one up now before we get to our case studies. So let me launch this first one, kind of about IoT devices and data loggers. So the question here is, what technology are you using to collect pressure, flow, water quality, or level data in your water or sewer system? We've got data loggers, other IoT technologies, you know, data loggers that have some wireless communication, or if you're using both, or if you're not sure, don't have any. Looks like in early voting, we're pretty well balanced, and we have a good chunk of the group connected right now that have both, which is great to hear, that people are starting to do that. I'll leave it open for a little bit longer. I also want to emphasize, we're going to do one more poll right after this one, but I emphasize, while you got your hands on your mice, as we go throughout this presentation, please use the question box to ask us questions, so that at the end we can have some good discussion. I'll go ahead and close this poll. I think we've got a majority of people in here. And then I will go back and start the next one. And this one's specific to just your experience with Scada Watch. Find out kind of the spread we've got here. So what's your experience with Scada Watch? Are you a user currently? Do you know that you have it at your municipality or at your law or at your consulting firm? Have you seen several webinars, videos, white papers, or is this your very first introduction? Excited to find out who we're reaching and Of course, tied to that, if this is your first introduction, if you see something you like at the end, we have another poll that talks about requesting more information. So pay attention there, and we can definitely get someone, or you'll see our contact information at the end too. Please just reach out to us, and we'd be happy to answer more questions as we go. That's excellent. It looks like we got a lot of newcomers on this one. I'll leave it open for about 5 more seconds. Anyone else? We have a couple users on board too. Excellent. Glad everyone is here. Let's see, I believe it should go back to my presentation now. Paul, do you see my presentation?
Not yet.
Is it still showing the poll?
Yep.
Interesting. Sorry for the technical glitch here. It looks like it really still wants to show us that poll. Maybe if I share the results with you guys, maybe it'll decide to let us go, so you guys can see how people responded. We've got a good mix here. Let's see if I hide that. Let's go back to my screen. All right, we got it.
There we go. Great.
Sorry about those difficulties. All right, so we're gonna talk about these case studies. I'm gonna turn it right over to you, Paul, and you can get going and showing off this stuff.
Okay, great, Brett. Thanks. So we have 3 interesting case studies to show you today. The first case study took place several years ago at a large utility in Florida, and it demonstrates the benefit of using a combination of data sources, real-time data sources, your IoT, your Scada hydraulic model, where we help resolve a widespread low-pressure problem during a transmission main maintenance period. The second case study describes a problem for a utility in South Carolina that was experiencing water hammer at a new sewer lift station that had just been commissioned, and how we use pressure transient IoT to quickly resolve the problem. And the third case study describes 2 utilities who are both struggling with low chlorine residual at a remote point in their system at a connected master meter site, and how we use some intelligent water quality monitoring and flushing IoT to help them solve that problem. Okay, in 2011, I was involved in an interesting project with a large firm here in the U.S., and there was a utility in Florida who wanted to complete a water distribution master plan and develop a CIP in a very quick time frame, in less than 10 months, and about half the time it might normally take. However, the utility had not developed a water distribution model, and aspects of their Scada system were near the end of life. They were in the middle of a 2-year Scada upgrade project, but the improvements weren't going to be ready for our project. So to address the critical timeline, my company developed a kind of a novel use of IoT Scada to help fast-track the model development. We deployed 8 edge devices, or RTUs, at existing pump stations and master meter sites that were supplying surrounding wholesale customers. We utilized existing pressure and flow instruments where we could. Others we had to swap out. And we pushed this data from the facilities to a custom website application that's shown there on the right. And as you can see, there's some red and green dots on it. They're representing both fixed and portable telemetry. So we also deployed 10 portable hydrant RTUs to collect pressure. We moved them all around the system to perform specific tests and to facilitate calibrating the model. And you can see there in the little picture on the bottom right, a hydrant being flushed, and all that data, flow data and pressure data from these tests are being uploaded to the website every 10 minutes. So we did this to help fast track the project, to make consolidate data all in one place, and so everyone could really interact together, both operational field crews as well as folks on the consulting team that are even out of state. And we were able to complete all of this work in less than 3 months, which was quite a feat. So at the core of the case study was an event that occurred during the project. So we knew, and part of the scope of the project was to address a maintenance period. They were taking one of their two intercoastal transmission mains out of service for maintenance for 2 weeks. And so we really were trying to push and get the model partially calibrated or mostly calibrated in time to use it for this period. They'd never been in this situation where one would be out of service. So to help operations and construction management, we deployed hydrant telemetry units on the active transmission main across the intercoastal waterway. And so this would give us better eyes on the system. In addition to data coming in from their facilities, we now had portable pressured units reporting data, so we could really see what was going on during this critical time period. So this just shows you the website application circa 2012, which is pretty nice at the time. You can see there's a trend chart for the pump station there, reporting pump station inflows and outflows and tank levels and pressures and pump status. These are all existing instruments that are there at the pump station, and we just piggyback on those signals without being on the Scada network. And so the green dot there represents a hydrant telemetry unit that was automatically would be tracked in the website environment, so you could see where operational crews were at any given day. This was a powerful tool that we had during the project, and this map is kind of a screenshot from the critical low pressure event that occurred real early in the morning. Utilities started getting a couple of complaints from kidney dialysis centers there on the island, not far from the line stop. So that kind of swung into some activities, looking at what might be the issue. Are we in trouble today? Fortunately, we had these hydrant telemetry units that were recording pressures that we could look at. This is showing you the different facilities, repump stations, the master meter sites, and the blue line representing the flow path onto the islands. So throughout the day, we started getting intermittent customer complaints and issues. And so the problem became apparent was a bigger issue. And so a little bit of panic starts to set in. So we started looking at the website in more detail and studying what was going on and interacting with operational crews on the ground, trying to figure out what's going on. The beauty of this is we're able to extract some good data and run it against the model, which in the next chart here will show us where the problems might be arising. We thought that we had a partially closed valve in the system, shown there with the arrow, but as we kept looking at things, it started pointing more to a repump station and how it was being operated. So this slide is showing kind of the hydraulic profiles that we're seeing at different time increments, combination of Scada, facility data, hydrant telemetry data, and it's showing a low pressure event. And because the model was ready in such rapid time, we're able to use it and compare it and really confirm that we didn't think there's any partially closed valves in the trunk system. So it started to look more like a demand issue, and it started looking more like a pump station tank fill operation issue. And so what we later found out that day is one of the shift operators at the treatment plant was refilling a repump station ground tank. And we didn't know at the time, but there's two high and a low fill rate valve. And Brett's going to show you some of this data in a moment in Scada Watch. And what we quickly learned by comparing the data we're receiving against the model is that we really just stressed out the system too far. So the high rate fill valve was being used, and that demand plus the inherent demands on the island just exceeded that single transmission main feed. And it was just, you know, it was a kind of a growing pain trying to learn how the system operated under this new kind of condition. The utility had never had both transmission mains out. So the beauty of this is these problems were identified within hours, and we really were able to focus on change very quickly. And, you know, the beauty of this type of system is it's not just operations, it's engineering. Your consultants who are helping you can all be looking at a common environment and all contributing to help solve the problem. So Brett, you're gonna, I guess, jump into Scada Watch for a second, and we'll look at some of this operational data at this repump station.
Excellent. So Paul gave me some of this data to just populate really quickly. He gave me kind of a snapshot of some of the data that happened back then. And I'm going to show you kind of what process I would have gone through if I had been dealing with this kind of live, and what it would look like in Scada Watch, and how I'd build the different charts. So in this first one, I've got the pressure for that Banana River, where the nearest situation to the complaints. I just ran a search for any pressures that were below 40, and it's showing me that there's 3 locations in this time period that go below 40. But if you notice on this left side that the PSI below 40, there's only one of them that looks like it's below 40 when you look at the hourly data. But there is kind of if you look at the minute data, you can actually see that there's a few spikes that are going down temporarily. So we really wanted to get to the bottom of what is causing that spike. So I want to go back to his map to explain the situation and explain what you're going to be looking at on the next screen. But as he mentioned before, we've got some data points from Scada in these red, these kind of permanent things. I'm going to show you what those pressures look like. We're going to start there. And then I'm going to show you how bringing in the temporary hydrant sensors for pressure can tell us quite a bit about the story as I add them to be viewed on the same screen. So this first one, and this is just a video of what I recorded earlier, but this is each of those pressure sensors from Scada on the island, showing that there's a big drop that happens at one point in the day. Now I'm bringing in and I'll bring them in kind of a different panel so that we don't get too much overlap and clutter on this graph. But we'll bring it in on a separate graph to start looking to see if the shapes of these things are similar. And what you'll notice is we do have some of the same shapes, we have some of the same dips, but this first yellow one was the farthest upstream, or the farthest away from the island. And as we add these other 2, they're the ones that get closer to the area where we knew we had low pressure, right, closer to the island. So what it tells me is, when we look at this, is this yellow one that's the farthest away does seem like it's dropping at similar times as the other kind of static location, the fixed locations. It's dropping at the same time, but not nearly as drastically as the similar units on hydrants that are closer. So you can see that number 2, number 4, and then number 6, we see it kind of progressively getting worse. And those, again, on the map, followed this path here. So the farther along, the closer we got to this problem, we see that it's getting more drastic. That's an indication that it's head loss related issues are probably from flow. So what I did after finding that out and seeing that expressed is I went back to my original banana, where I found the issue, and I decided I would look at the other sensors that are around there. So I can search for banana. I see I've got an inflow flow rate. So as that tank fills, I can compare that to the pressure, and I can instantly see, if I put them on the same graph with a different y-axis, I can instantly see exactly that it was the filling of the tank that causes, there's a direct correlation between the filling of the tank that you can see in orange and the pressure in the system. Again, the main thing that we realized, or that they realized in the project, was the fact that there's a normal valve that's generally used to fill that tank. We see kind of indicated at this level, that's about somewhere just over 2 million gallons a day. And when they opened up that high flow valve, it jumped up to almost double that, and that's when we have a problem. So we have a line that's just too small to carry that, that mass. We can't double the capacity and not expect to have a a pressure issue. So it was just really cool to be able to come in here quickly. I brought in his data, I connected it, and was able to start visualizing this data all in just a couple hours. If you have this already installed in your system, the biggest part of that was installing it, right, to get the data into it. If you're on your own system and it's live data coming in, then that part's already done. You just get to visualize the data. And not only that, but the same search that I used to find that low pressure, you can apply on a regular basis and have it text or email you when you have one of those spurious data points or something that you have concerning you. Paul, let's go ahead with second case study.
Okay, great. Thanks, Brett. So the second case study is very interesting. It's an operational issue within a larger project, a wastewater model and master plan project. And it was an event that occurred last summer during a field data collection program in which we were performing manhole flow, rain gauge, and lift station pressure telemetry. And during the summer, a new regional pump station was commissioned, and operations was having a really tough time with pump vibration, and was just struggling. The design consultant wasn't quite sure what was going on either. And so operations was out there in the field constantly trying to change some of the pump operation. They thought it might be airlock, and we're running the larger pumps once a day and trying some different things, but they really just weren't getting very far. The problem was getting resolved. So this case study demonstrates how deploying the right IoT device, during a larger field monitoring program really instantly paid for itself just to help address this chronic pump problem. So this pump station consists of one small pump and two large pumps, each with variable speed drives. So operations was running the small pump at reduced speed, and oftentimes when new lift stations are brought online, they're obviously designed for future conditions, so flows are a little low, and so they're running this first small pump at very low speeds and low pressures, and then once a day running the large pump to flush things out. However, the pump operation just getting a lot of vibration on both pumps, and just having issues they couldn't quite resolve. So I just wanted to show you real briefly a little bit about the technology that was used. The Swim Pulse Pressure Transient Analyzer is a unique IoT technology with 4G LTE communication data that's being uploaded to our Swim Connect website. Could also be upgraded or uploaded to Scada system. But what's really unique about the system is its ability to really scan fast, up to 2,000 hertz or data points per second. This is really the fastest water IoT analyzer in the world. We're also performing some edge computing. We're deconstructing the waveform, trying to tease out specific information. We really don't want to try to upload 2,000 data points per second to a website over the cellular network. That's just not practical. So we actually tease out specific information to deconstruct that waveform, which you'll see in the next chart. So after watching the data for a couple of days, we started seeing a very obvious problem. The small pump there in the center graph in the middle, we got a small pump operating only at like 3 psi, and we're seeing a lot of water hammer during shutdown. Transient pressure was peaking at 30 with a -7 low pressure, and also the large pump having the same problem. And so this became more and more clear what's going on is that we were kind of self-sabotaging ourselves and pulling air into the line by running this large pump. It wasn't really serving its purpose. So we played around with some of the control logic and had the pumps ramp down at a slower speed, and we do iteration over a couple of days, figured out if we just slowly ramp the pump down, we could keep pressures positive. And so you can see in the second chart, the large pump is running and you don't see that pressure transient occurring, and pressures are staying positive, which means we're not entraining air every time the pump shuts down. So this was just a very, quick, short duration dialogue we had with engineering and operations, and we're able to resolve the problem very quickly. A lot of water hammer and surge problems require complex modeling. A lot of times we end up recommending surge tanks, but this problem was just solved through operational controls, which is really the best ending you could hope for. So Brett, you're going to jump in SCADAWatch and just show how you guys render transient data in SCADAWatch.
Yep. So Paul, a few years ago, gave us, working together on a project, he gave us some transient data. So I'll show you again. You can look up the sensor that you're interested in. This is kind of standard pressure data coming in to start. So we've got kind of the 5-minute data that will zoom into a specific area, and you'll see that there's not always a good indicator that there's transient. Sometimes you get a spike that might give you an idea that there might be something around, but you don't always. When you enable transient data, what SCADAWatch is doing is it's connecting it to that way higher frequency data where it's already identified that there's an issue, and it will tell you exactly where it is with that red indicator. You can click on that, and then it will automatically bring you over to your kind of normal sinusoidal curve that we're used to seeing for transients. So not much more to say there. The data comes in lots of different formats. We've had some experience in putting it here with some things that Paul's already done in the past. It's just fun to be able to visualize that right alongside all of your other SCADA data and other things going on. So I can actually see, you know, at a pump station that might have multiple pumps, I might be able to see which pump turned off that correlates with that time of transient data, or which valve was closed at that time, because all the data is in one place.
Thanks, Brett. So our next case study is about 2 water systems struggling with a low chlorine residual problem at a remote part of their system where they have an interconnection, a master meter. The receiving water system is smaller, has had trouble with an intermittent raw water supply. So they sometimes have to rely on the larger water system at the master meter connection. Because the interconnection points are relatively long pipelines with no customers, the water age can be an issue and ends up with low chlorine residual problems. So they're having to do a lot of manual flushing before they open that master meter valve. And so how do we maintain chlorine residual on both sides of this master meter, even though the smaller water utility really doesn't want this master meter open all the time? And I think there had been a little bit of challenges with water quality in the past. So how can we facilitate getting good information and coming up with a permanent solution? I just want to show you briefly the technology that was utilized. So this was a temporary install. It's been installed for maybe a year, but we put out our swim pulse water quality analyzer and intelligent flusher, and we can monitor various parameters based on the project, whether it's free or total chlorine. For this project, we were monitoring turbidity as well in the upstream, free chlorine and pH and temperature. And the beauty of this kind of system is it takes about 30 minutes to install, and then data is hitting the website, and you're controlling the amount of flushing that's occurring in the for your analyzers and for your piping network, and you're keeping water quality at your desired target regulatory requirement. So this last slide is just going to show kind of a schematic of the situation. And so you see on the right side, we've got our supply side water, system B. On the left, we got system A, the smaller system receiving. We've got a master meter station that's normally closed, and we're having to flush a lot on the upstream system to ensure our water quality is adequate when they open up that master meter station. And so we installed our temporary systems to help minimize that travel time and maintenance requirement, and to keep chlorine residual up to where it should be on both sides of the system while this master meter station is off. And the beauty of these type of systems in IoT is we can share some of this data through the cloud website. Obviously, it's very difficult sometimes to share SCADA systems between two utilities, so this was a way for data to be shared among two separate utilities to get a handle on what's going on from a water quality perspective. Another interesting thing is being able to push data twice, one to the website and do another push over the cell network to the SCADA system to a separate IP address, and that was for the receiving water system. And so ultimately, common sense would say, hey, let's just get an ideal flow moving through the system to keep water quality and water age from getting out of control, and have some minimum level of water going through the master meter station. And so the beauty of this kind of system is we can do totals on how much flushing is occurring. We can kind of get a gauge on what we need to do in terms of flow at the master meter station going forward. So I think in the near term, they're going to install a smaller bypass and we've got some target flow rates that I think the smaller utility is willing to live with. And part of their challenge was dealing with some ongoing capital connection, recurring charges, and just the water usage. They're trying to minimize that situation. So this just kind of represents a kind of really unique situation that two utilities were really working together to kind of solve a minor problem and working with a temporary solution towards a more permanent solution. So just wanted to give you some final thoughts. Water and wastewater operators, you guys have incredible responsibility to provide fresh and clean water to our cities, to our customers, and dispose of wastewater safely to protect the property and environment. And these case studies just represent a glimpse of the type of problems that you guys deal with day to day, and how if we leverage all these different data sources in real time, how both operations and engineering and consultants and contractors, how we can work together to really solve these type of problems. And I think being able to pull this data into a simple, powerful software like Scada Watch can really empower all of our entities, whether you're field ops or plant ops, engineering or consultants, and even your technology vendors that have, unique specialties. How can we all work together to solve these problems to improve, customer service as well as save time and money? So, Brett, I think you had some final thoughts.
Yep, I just got one more slide just to kind of highlight what you've been talking about and what we've been discussing all day today is the idea that we have data sources at our disposal already, right? Most systems have SCADA. There's a wide variety on how, what extent they're using that data and how many sensors they've got out in their system based on SCADA. But SCADA is definitely a critical element in almost all these systems, necessary for actually controlling the system and to do that emergency critical response type stuff that we all know is important in those systems. We've got IoT that gives us the opportunity to have some more flexibility, a little faster implementation, maybe easier to deal with than having to coordinate with everyone on the security side of something in SCADA. Generally more in the retrieval of data instead of the controlling, even though there are some definite reasons why you might want some control there, and just getting more and different data. And then thirdly, the hydraulic model, basically being able to see information between the sensors and to be able to test out different scenarios and what you might want to do to solve a problem that you see out in the field. This is the stuff that, the combination of these three things is what is the exciting part of a water utility. These systems are always changing. There's always things that we need to do that we've never done before, and we don't know exactly how it's going to react. Using these three tools together give us the best chance to really be able to work efficiently in our systems and to optimize things and to solve problems quickly. So I personally, my career path kind of changed to starting to work at Innovyze to kind of help, develop this story. And I saw the early workings of Scada Watch and trying to bring some of this data together while I was still a consultant and having a lot of fun implementing this with a lot of different utilities globally and seeing the creative ways that people use this data once it is all at their fingertips. And a lot of that can go back to projects that are important, like the ones you showed, Paul, today, that really kind of was pioneering this vision. And I know working with you throughout the years on some of this stuff has definitely given us what we have available today, and are driving these discussions and the different presentations like the ones at WEFTEC that you're talking about in the city of Atlanta and things like that, that people are recognizing the importance of keeping all three of these data pieces as up to date as they possibly can. We do have a couple questions here. This one is always brought up in presentations when the Scada word is mentioned. The question is about security, and we talked about it a bit today. It is important to keep that secure, and it's top of mind of anyone that works on Scada, because Scada can control things. It's very critical that stays protected. The way Scada Watch connects to that data is through the historian. So Scada records the data and pushes it off to another historian database, where all the gobs and gobs of data are sitting there. It's usually on a different side of firewall than kind of Scada proper that's doing the controlling. And Scada Watch will connect just to the historian, not to the regular Scada, which is near live, a second delayed in some cases, but it's read-only from that historian also. So even the historian data is, we cannot alter it. We don't want to alter it. We're just bringing that data into Scada Watch so that it can, so we can do all the metrics and the fun calculations that we want to off of it. Another question is that I see here is basically, how are you talk about bringing in a lot of different IoT devices, and Paul, this is aimed at you here. How does it work integrating some of that data? I'm assuming it's all different formats and all different ways that they're used to delivering that data. How have you dealt with that the best in your projects?
Right. I think a lot of utilities, have a mixture. They have maybe they've got their SCADA systems. They've got some data loggers they've been using for years. They might have some new IoT devices. They might have multiple IoT vendor devices, maybe solving different problems. And so how would you start tackling these different data sources? And so, some techniques, all of us have dealt with spreadsheets and trying to look at time series data, and it can be quite a nightmare, especially if you're looking at pressure transient water hammer data. It's just almost impossible to navigate that in spreadsheet environments. So these applications that are built like Swim Connect and Scada Watch, and it's the ability to quickly compare and zoom into and analyze data quickly that you just can't do in that spreadsheet environment. So a lot of times the static data sets, it's worthwhile to push those into Scada Watch through, an FTP push. Different technologies have different capabilities, but I think CSV format is often a simple way to push data to the Scada Watch server. There's just a lot of ways to do this, and one unique project that we worked on together for the Scada Watch application, we had Scada Watch reach out over the cloud to another SQL database and pull that data in. So there's just a lot of ways to approach it, and each utility is different. Going back to the first question, every utility has different culture and different needs and different requirements, and some SCADA systems just need an air gap, and they're not going to budge on that. So, like in the case study we showed, we were able to still leverage sensors and instruments that are out in the field and piggyback and grab those signals without being on the SCADA network. So it's a completely safe approach. So there's just a lot of different ways to get to the data and pull that into the environment that you need. So every utility is unique and different, but I think there's always a solution.
Yeah, we've had the same experience. Another question that kind of ties into all of this is what kind of SCADA historians have we connected to? Do we have to have a specific one? We've made Scada Watch particularly open to anything that can do kind of an ODBC connection. So we've had lots of experience with some of the bigger names where we see them more frequently, and others that are smaller, we've been able to connect to them as part of our implementation services. We get that all connected and provide everyone else with just the training that they need to continue to maintain that and to update. You get a new sensor. The idea that we're talking about these IoT devices is that hopefully once you start to visualize that data, you're going to be putting more on, right? And there may be a new kind of sensor that you've never done, but we really emphasized the ease of a simple user being able to add some of that stuff themselves and not need to have a programming degree to have to figure that stuff out. Do you see any more questions? I think we've covered most of them.
I think that's it.
I think we're good. All right, well, the last slide here is just our contact information. So please, as I mentioned, reach out to us. If you had questions from this, if you want to see an in-depth demo, if you need Paul's services to try to figure out a particularly tough problem and trying to figure out which devices would be best to use in a certain situation, he knows these things well. So please reach out to us. We're putting our information here on purpose. We want you to contact us to help answer any questions we can. But thank you very much for coming, and I think we'll be signing off.
Thank you.